In the last section, we were talking about writing linear equations from graphs and from context. Today we're going to talk about writing linear equations from tables and patterns. So tables and patterns. And when we say tables, what we have is we have a bunch of data that's organized in a table. So we've got some numeric data. So let's take a look at the warm-up here. It says, what is slope-intercept form? Gosh, we got to have this down by now. Y equals mx plus b. Next question, what is the x-coordinate of all y-intercepts? Remember, if you're on the y-axis, that means you didn't go right or left, so that means the x-coordinate would have to be 0. It says find the slope from this point to this point, so we're going to use that formula right here. Again, got to have these memorized, so y2 minus y1, x2 minus x1. Again, I kind of like putting that minus in the middle of the top and bottom so I don't miss that. We're going to do 2 minus minus 1, so 2 minus minus 1. We're going to match these up, and then we're going to match these two up, so x2 minus x1 is negative 4 minus the 2 there. This becomes a plus, so that's going to be 3 on the top, and that's going to be negative 6 on the bottom. So we'd simplify this to the fraction negative 1/2. And then it says y equals mx plus b if the rate of change is negative 2/5 and the starting point is 7. Remember, rate is another way to talk about slope, and starting point is another way to talk about the initial point or the y-intercept. So they're really telling us, even though these are fancy words, they're really telling us that this right here is the slope and this right here is the y-intercept. So we're going to write down y equals, we'll write negative 2/5 x and then plus 7. So we've got that one taken care of. And it says use the pattern in the tables to find the point 0, comma, whatever that happens to be. So let's take a look at this one right here. We're going to write our answer right above, but let's follow this pattern. So 1 corresponds to 10. 2 corresponds to 7, 3 corresponds to 4. So notice that this is counting up by 1 every time. So we go 1, 2, 3, the next one would be 4, and so forth. And we go 10, 7, 4. Now if you'll notice here, we're going down by 3 every single time. If the one that we want has an x of 0, let's take a look and spot this pattern here. We're basically, if we go backwards through this list, we're counting down. So 3, 2, 1, and 0. And what we want is this value right here. So if we're counting down here, let's see what's happening here. We start at 4, then go to 7, then go to 10, and if you'll notice, we're adding 3 units every single time. So this would end up being 13. So I'm going to put a 13 right there, circle that one. You might be able to think of another way to do this one. We could use the rate of change. We could calculate the slope here. We could find the difference between the two of these and the difference between the two of these, and then we'd be able to tell what our slope is or what our rate of change is, and then I think we'd find that it's 3. So going this way, it's going down by 3, and going the other way, it's going up by 3, if you want to think of it that way. And then let's take a look at this one. Notice we've got 2, 4, 6. So if you'll notice the pattern here, if we're counting up by 2, going the other way, we'd have to count down by 2, so this would be 0. And then here we're going 8, 13, 18. So going from here to here, we're counting by 5 each time. So going the other way, we'd count down by 5. So 18 minus 5 is 13. 13 minus 8 is 5. 8 minus 5 is, this would be a 3. So 0, 3 would be the point that we're after. Now that's going to be very useful in what we're going to do today, because again, we're writing equations from tables and from patterns. So let's take a look here. There's a box right here. I'm hoping you can fill this in. It says to write the equation of a line, we will always need 2 things. We will definitely need a point. Doesn't have to be the y-intercept, but that's kind of helpful. And we'll need the slope. Okay, got to have a point and a slope in order to write a linear equation. So we're going to practice writing linear equations in, again, slope-intercept form. That's kind of our favored form for right now, using tables and patterns. And we're going to find the starting point. And when we say starting point, that's another way of talking about the the y-intercept, and it's definitely got an x-coordinate of 0. That's kind of be like our timekeeper. When 0 is x, that means we're kind of starting a stopwatch. We're starting the whole experiment or starting the observation or whatever it happens to be, and that's what our starting point is going to be. And then the rate of change And remember, the rate of change, aka, or also known as the slope. So it says write the equation for each table in slope-intercept form. So let's take a look here. You'll notice that on this one we have something nice. This is the y-intercept right there. Okay, so I'm going to write y-intercept right there. If we have a point that says 0, comma, whatever the starting y value is, that's our initial point, that's our y-intercept, that's the b in the equation, y equals mx plus b. And then in order to figure out what the rate of change is, or what the slope is, we're going to need to use our slope formula. So I'm going to do y2 minus y1 over x2 minus x1. So that's going to be a 1 minus a 3, and that's going to be a 2 minus a 1. So that's going to be a negative 2 over 1, so that means our rate of change is negative 2. Now what I'd like you to take a look at here is I want you to start noticing the patterns that you can see in the numbers. Notice that these are going up by 1 every time, so 0, 1, 2, 3, 4, and so forth. But notice what's happening with the numbers or the values for y. We start off at 5, go down to 3, go down to 1, go down to negative 1, go down to negative 3. So what we're doing here is, notice the slope has a negative in front of it. That means that these numbers are getting smaller. We're taking off 2 every time. So the rate of change is negative. So instead of these numbers getting bigger like the x's are, they're actually getting smaller. So we'll write down the equation y equals, this would be negative 2x, that's the rate of change right in front there, and then plus 5. So it starts off at 5, and then every time we count up 1 for the x's, we're going to take off 2 for the y's. Okay, let's take a look at this one. You'll notice that there's a blank right here, so there is definitely something missing. And what's missing is that y-intercept, that starting value. So we have something that's kind of advantageous on this one in the pattern. It goes from negative 1 to 1 to 3 to 5. So you'll notice that it's skipping 2 units every single time. So right in between those two, negative 1 and 1, would be 0. And then what's happened here is we go from 5.5 to 4.5 to 3.5 to 2.5 and so forth. The next one would be 1.5. So if this one is right in between the two of those, if 0 is right in between negative 1 and positive 1, then let's take a guess at what would be right in between 5.5 and 4.5. Well, if you a lot of times thinking in terms of money is helpful. So this is $5.50, this is $4.50, so right in the middle of those would be 5. So here is our starting value. Now I want to kind of introduce something to you that may be helpful in the long run. I was talking about kind of counting up by 1, and as these get bigger, we can kind of think of this as a starting point, like a stopwatch. So when x is 0, that's like when we start our stopwatch and then we're counting up by 1 minute or 1 second or whatever it happens to be. What we've got here is, let's say this is where we start our stopwatch, and then we're counting 1, and then like 3 minutes after we start it, 5 minutes after we start it, and so forth. This negative would kind of represent going back in time, if you want to think of it that way. So here is our y-intercept. And then in order to find the rate of change, let's do this. I'm going to pick two that I haven't written on before. So we're going to do this. So this is going to be 2.5 minus 3.5 over 5 minus 3. So this is negative 1/2. Negative 1, and then divided by 2. So this is going to be, now this has decimals in it, so I'm going to say negative 0.5. So this right here is our rate, or that's our slope, and this right here is our y-intercept. Okay, and that's negative. Okay, so we had the negative 1 divided by 2, so negative 1/2. Let me make that look a little bit better. Okay, so negative 0.5. I'll even put the 0 there. Okay, so we've got our rate of change, and if you come back up here and take a look at the table, this kind of makes sense, because what's happening is we're going down. Slope is negative, or the rate of change is negative, so we're going down by half a minute or half a unit every single time we change 1 minute or 1 second, however you want to think of that. So we're going to go from 5.5 to 5 to 4.5. The one in between here would be 2, and that would be 4. and then we'd go down another half a unit, and then the one in between here would be 4, so this would be 3, and so forth. So we really are going down a half a unit every single time the x changes. That's our unit rate if you want to think of it that way. So we get y equals, this would be negative 0.5x, and then plus 5, so I'm going to go ahead and circle that one. And then let's take a look at this right here. This one is a little bit on the challenging side, so let's take a look. Unlike this one where we had something right in between, 0 would be right here, but it's not, 0 would be right in between here, but it's not right in between -2 and +1. So what we can do is we can do this. Let's go ahead and find the rate of change between these two, okay? So this is going to be 36 minus 6 and 4 minus 1. So that's going to be 30 divided by 3, so that's going to be 10. And let's just double check. It is positive. Yeah, according to our calculations, it's positive. And that should make sense because these are getting bigger and these are also getting bigger. So that looks pretty good. So here's our rate right there. Okay. Now, in order to find the equation, here's what we're going to need to do. We're going to say that y equals, this would be 10x plus b. We don't know what that is, but remember, they've given us a whole bunch of points right here, so we should be able to figure out what that starting point is, what it is when it's 0. And the way we do that is we're going to plug in one of these points. Now, I'm going to plug in the easiest one, okay, and I'm going to change colors for this. I'm going to plug in this point right here. So I'm going to put a 6 right here. I'm going to put a 1 right here, and then plus b. So this is a 10, so I'm going to subtract 10 from both sides, so I get a -4 over here, and I get a b right there. Okay, so I've got the slope and I've got the y-intercept there. So we're going to write down y equals 10x plus minus 4. 10x minus 4. Okay, so there is the equation. Now let's check and see if this actually works. Unlike these two problems over here on A and B where we had an initial point, we had that y-intercept. This one we didn't, so let's check and see if we've got this equation right. If we were to plug in 4, 36, let's check and see what happens. If we plug in a 4, that would be 10 times 4 minus 4. That would be 40 minus 4, so we'd end up with 36. We end up with the correct value right there. So that looks good. Let's check another one just to make sure. Let's plug in -2. So 10 times -2 minus 4, that would be -20 minus 4, and we get -24. So that equation describes what's going on in that table. So if they give us the y-intercept, that makes things really easy. Really all we need to do is provide the rate of change. This one was a little bit tricky, finding the y-intercept, but we could kind of do that by just kind of logic and reasoning there. This one we had to find the rate of change, plug that into the slope-intercept form, and then plug in another one of these points in order to figure out what the starting point was. So what we're saying here is the starting point on this one would be, if we wrote it down, would be 0, -4. Okay? And if you think about this, with the rate of change being 10, if we count up by 10, if we add 10 to this side right here, -4 plus 10 would be 6. All right, so we're in good shape there. Now that takes care of being able to find equations from tables. Let's take a look at finding equations from patterns. So I've got this example number 2 right here. It says study the following pattern of figures, then draw figure number 4 and 5, complete the table, graph the data, and write an equation to describe the situation. And it says you may need to complete the table after you have done the equation. Okay, so let's take a look here. We've got this diagram right here and it has 2 dots on it. And then in figure 2, it has more dots in it. It actually has 1, 2, 3, 4, 5. It has 5 dots. Figure 3, 1, 2, 3, 4, 5, 6, 7, 8 dots. Okay, so figure 1 has 2 dots. Figure 2 has 5 dots. We said figure 3 has 8 dots. So let's see if we can spot the pattern here. This appears to be going up by 3 every single time we add a number, 1 to the number of the figure. So let's see if we can spot what's going on here. We had these two originally, okay, and then it looks like one dot was added up here and two were added over here, okay. So here's the previous one, okay, and we added one dot here and two dots here. So I think that's what's going on. They're adding a dot here and two dots on the bottom. So this next one would be, let's draw that original figure. Okay, so that's figure 3, and then we're going to add one more dot here and two more dots here. So let's check and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we get 11, and that does fit our pattern right here. We added 3 to 8 to get 11. So this next one better be 14. So let's check and see what happens. We've got 5 dots here, and then let's see, counting over. Don't count this one twice. We've got 1, 2, 3, 4, 5, 6. Yep, so 1, 2, 3, 4, 5, 6. And then we're going to add 1 up here and 2 over here. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we got 14. So the next one, figure 6, would have been, let's see, add another 3, so that would be 17. Now it skips a whole bunch. It skips to figure number 10 and then figure 100. Now to figure that out, that might be kind of tough. We might have to write down some things somewhere else, but it does say you might need to complete the table after you have done the equation. I definitely think that's the case with this one. Let's see if we can figure out what figure 0 would be, like what the starting one would be, like when we started our stopwatch, if you want to think of it that way. If these are counting up by 1 and these are going up by 3, if we went backwards on the list, we're going down 1, down 1, down 1, and so forth to get back to 0. So this would be down 3, down 3, down 3. So if we backed up 3 units, that would get us to -1. Now that may not make a whole lot of sense if we're talking about how many dots there are in a figure, but mathematically and numerically that type of data does work out. So let's go ahead and graph the data. So we've got 1, 2, we've got 2, 5, and I'm just doing the ones that we had originally, and then 3, 8. 3, 8 is right here. 4, 11. 4, 11 is right there, and look how that's making a nice line. And then we've got 5, 14. So we've got a line that looks something like this. Now what I'd like you to look at is, watch what happens when we go past here. So when we try and get to 0, if we fit with this, it really does look like it's going to cross at -1. So that's going to be our y-intercept. So our starting point is going to be 0, -1. Our rate of change, we're going up by 3 every time, so our rate of change is going to be a +3. That positive indicates that it's going up. And then our equation is going to be y equals rate of change times x, and then the starting point or starting value, initial value, would be -1. And there's our equation. So we've got all of that information right there. Now we've got enough that we can finish off the table. So let's go ahead and do this. What if we were on figure number 10? If we put a 10 right here, that would be 30 minus 1, so that would be 29. So let's put a 29 right here. If we did on figure 100, this would be 3 times 100 minus 1. So that's going to be 299. So 299 right here. Okay, certainly wouldn't want to draw that. Glad they just asked us to fill in the table. So let's make sure that we've done everything here. We've drawn the figures. We've completed the table, we've graphed the data, and we've written an equation to describe that situation. So we're going to flip over to the other side and we're going to do one more. So I flipped over to the other side. We're going to do this last example, example 3. It says basically the same instructions, but we don't have to draw as many of the figures. So it says study the following pattern of figures. Draw figure 4, write an equation in slope-intercept form to describe the number of O's for any figure that follows the pattern. We don't have to graph this or anything. All we need to do is come up with an equation. So we start off with 2, and then we've got the 2 that we had originally, and then notice we've got 4 more. So let's see if that happens every time. Do they add 4 more? So there's the previous one, and then 4 more. So figure 4 is going to be Let's see, here's figure 3, if we just draw that. And figure 4 is going to be one more set of 4 O's, and figure 5 would be another set of O's, and so forth. So let's think about what's happening here. From figure 1 to figure 2, we added 4 more O's, added 4 more O's, added 4 more O's. So what we're doing is we're adding 4 O's every single time. So that means the rate of change is 4. It's positive 4, okay, because we're adding 4 of those O's every single time. Now let's see if we can do this without the table. Let's kind of go backwards. So if we were going backwards, this would go from this many O's to this many O's. We'd be taking off that last row of O's. We'd be taking off these 4 O's to get to this one. And if we took off 4 O's, that would be like having figure 0. Now again, this doesn't work in the physical world, but if we counted up the number that there were 2 here, there were 6 here, there are, let's see, 10 here, and there are, if you add those up, there's 14 here. So if we go backwards, on figure 0, this would be negative 2. And then we've kind of got this pattern where we're adding 4 every single time. So this right here is the initial value, okay? The start point, or the y-intercept. Okay, so if we know what our starting value is and we know what the rate of change is, then we can write down y equals, this would be 4x minus 2, and circle that, and we've got the equation. Now let's see if this actually works. Let's go ahead and write down that on figure 1 we had 2 O's. On figure 2 we had 6 O's. On figure 3 we had 10, and on figure 4 we had 14. So if we had to make a prediction, this is counting up by 1, so that would be a 5, and this is counting up by 4, so that would be 18. And if you stop and think about it, figure 5 would look exactly like this. We'd just have another group of 4 here, so that would be 16 O's in this big rectangle right here, and then we'd have 2 more, so that would be 18. And then going backwards, if we're counting down by 1, so this would get us to 0, then we'd count down by 4, so subtract 4, subtract 4, subtract 4, subtract 4, that would get us to negative 2, okay? So several different ways and approaches to do that. Again, the nice thing about this one is we just had to come up with the equation. The rate of change is 4, positive 4, because we're adding 4 every time, and if we kind of went back in time or went to where this would start at figure 0, we would have had to back up 4. That would put us at negative 2. All right, good practice here, a lot of good thinking skills, going to be very valuable in the future. Good luck with the assignment.